Okay. Hello future doctors and engineers. Welcome back to our online classes. Today we are discussing about motion in a plane. It is the fourth chapter in +1 physics. Also, it is very important chapter in +1 physics because concepts and equations of these chapters are taken in every chapter in +1 and +2. So it's a very important chapter. Motion in a plane. What do you mean by a plane? In previous chapter we are discussing about one dimension, that is motion which can be described by using only one coordinate. This is 2D, two dimension. We want two coordinates. To describe this motion. For example, in 1D, only one axis is required. Maybe it's X, maybe it's Y, maybe it's Z. Here we have one coordinate, three coordinate X, Y and Z. In 2 dimension, we want minimum 2 coordinates to explain 2-dimensional motion. That is motion along a plane. What is a plane? This board is a plane. Consider this is x-axis and this is y-axis, or this is x and this is y. Then this board is an xy plane. Okay, this board is an xy plane. If an ant or a boy, a spider boy, he is moving through this board. Like this. His motion can be explained by using these 2 coordinates, y and x. So that is a 2-dimensional motion along a plane. That is we are discussing in this chapter. So in motion in a plane, we can classify it into mainly 3 parts. First one, vectors. We have to discuss about vector concepts in physics. Next one, projectile motion. And last one, circular motion. These are the important and main topics in motion in a plane. What do you mean by a vector? And what is concept of projectile? And what is circular motion and its equations? Okay. First, we have to classify quantities as scalar and vectors. What is a scalar quantity and what is a vector quantity? It's a very familiar term. Scalar means quantity having magnitude only. For example, work, distance, speed and pressure. These are examples for scalar quantities. Which are vector quantities? Quantities having magnitude as well as direction. Quantity having both magnitude and direction. If we want to convey idea about displacement from A to B, we have only one particular direction, that is this direction. Only we can measure displacement through this direction. So displacement is a quantity having only one direction and it has one magnitude. So it is a vector quantity, displacement. Next one, another quantity is velocity. It is displacement by time. So velocity is also a vector. Acceleration is also a vector quantity. Also momentum. Momentum is a vector quantity. And kinetic energy is a scalar quantity. Energy is a scalar quantity. Okay. There are various type of quantities in physics. Something which can be measurable. That is called quantity, physical quantity. Length, we can measure it. Breadth, we can measure it. And time, we can measure it. That all are physical quantities. that physical quantities are classified into two, scalar and vector. Quantity having magnitude only, quantity having magnitude and direction are called vectors. Only magnitude they are called scalars. In this chapter, we are discussing about vectors. What do you mean by vector? I already told that magnitude and direction, having magnitude and direction. How we can represent a vector? Like this, a tail and a head. Consider this is vector A. What is tail represents? Tail represents magnitude and head represents direction. Okay, head represents direction. This is the representation of vector A. This is another vector B. Okay, in written format we can represent a vector like this. This is known as vector B, or this is known as vector A, or write it as bold letters. This is also known as vector A. Okay, this is not important. Like this we are representing vectors. Okay, if magnitude of this vector increases, so we can increase the length of tail, not direction. Direction is same, but magnitude increases, then means this length of tail will increase. Okay, so tail represents magnitude and head represents direction of vector. Okay, next one, types of vectors. Types of vector. Which are the various type of vectors? First one, equal vectors. Equal vectors. What do you mean by equal vector? Consider two vector A and B. If their length, that means magnitude, and head, that means direction, both are same, then we can set to be A and B are equal vectors. If two vectors has same magnitude and the same direction, they are called equal vectors. Second one, negative vector. Negative vector. What do you mean by negative vector? Consider vector A and vector B. For vector A and B, direction are different, opposite, but the magnitude are same because their length are same. Their length are same. That means magnitude same. Magnitude same, but the direction opposite. Direction is opposite. Such vectors are called a negative vector. Okay. Number three, coplanar vectors. This is very important. Coplanar vectors. If two vectors are lies in same plane, if two vectors are lies in same plane, such vectors are called a coplanar vector. For example, this is vector A and this is vector B, and these two are lies in a single plane. These two are in this plane. This board is a plane. I already told that. In an xy plane, motion of this board, motion of object in this board can be explained. So this board is a plane. These two vectors are lies in same plane on a board. Clear? That means they are coplanar vectors. And another one, number 4, non-coplanar vectors. Non-coplanar vectors. What it means? Because consider this is a vector and this is another vector. These are non-coplanar vectors. This lies in this plane and this vector not in this board plane. Okay, so this is non-coplanar vectors. Two vectors which are in different planes. Okay, and next one, fifth one, collinear vectors. What do you mean by collinearity? Consider vector A, another vector B. If two vectors which are acting on same line or parallel between lines, that means these two vectors are maybe in same plane or these two vectors are in parallel direction. Okay, these two vectors are parallel, so we can set to be, that is collinear vector. So what is collinear? Acting parallel to each other. Acting parallel to each other. Another one, sixth one, co-initial vector. Co-initial vector. What it means? If a vector start from this origin, this is vector A. Another vector B start from this origin. So common origin point. A and B has common origin point. So they are called co-initial vector. They are called co-initial vector. Number 7. Coterminal. Very simple. Coterminal vector. What it means? Two vectors are end in same point. Their heads are joined together. Heads joined together. Coterminal vectors. Clear? These are the type of vectors. Here, equality of vectors is very important. What is the importance? Consider vector A. Vector A. I can plot that vector A also here. This is also vector A. Why? This is vector A. This is also vector A. Because irrespective of their locality in space, a vector can be transformed. I can move this vector parallel because equality of vectors, same direction, same magnitude. I can plot this vector A here. Same magnitude, yes, same direction. Head is like that direction. Here is also that direction, that direction. So I can write or I can plot a vector A in any other point in this board because vector A can be transformed or any vector can be transformed irrespective of their locality in space. I can write it as here. This is vector A, same magnitude, same direction. Check if the directions are same and magnitude are same, they are equal vectors. So this vector A, this is also vector A, this is also vector A, this is also vector A. A vector can be, very important point, a vector can be transformed, a vector can be replaced, a vector can be replotted without respecting their locality in space. Firstly he is here, but it is not necessary to plot vector A only in this position. It can be plot like this because they are equal vectors. Same direction and same magnitude. Tail represents magnitude. Okay, so this is a very important point. Irrespective of their locality in space, a vector can be transformed. Okay, next, unit vectors. There are three unit vectors, I, j and k. I cap is the unit vector in the direction of x and j cap is the unit vector in the direction of y. K cap is the unit vector in the direction of z. X, y, z are mutually perpendicular directions. Okay, like this, x, y, z. I cap is direction of x. For example, a man moves 10 meter x direction, 20 meter y direction, 10 meter minus z direction. We can represent it like 10 I cap plus 20 j cap plus minus 10 k cap. This is the displacement of that man. How can find out that value of displacement? Find out this modulus of s. Modulus of s is equal to root of 10 square plus 20 square plus minus 10 the whole square. This is the answer. Calculate this and that is the answer. So I, j, k are used to find out simply the physical quantities. So calculations are very easy by using I, j and k. Okay, these are also known as orthogonal triad. What do you mean by orthogonal? 90 degree. Tri means 3. I, j, k. There are 3 unit vectors. They are called orthogonal triad. Next, resolving of vectors. Resolving of vector. Consider this is vector A. It can be resolved into A cos theta and A sin theta. A vector can be resolved into infinite number of components. A vector can be resolved into infinite number of components. But this type of this type of componentization is called rectangular componentization or rectangular resolving. Okay. What is it called rectangular? This is a rectangle. Okay. A sin theta, A cos theta. Ax is called direction of or component of A in the direction of x. What is Ax? Component of A in the direction of x. What is Ay? Component of A in the direction of y. This is y direction, this is x direction. This is our vector A. It can be combined into two, Ax and Ay. What is Ax? A cos theta. This is theta. Theta is the angle made with horizontal. Vector A, angle made with horizontal is called theta. So this is A cos theta and this is A sin theta. This is called a rectangular componentization. Rectangular componentization. Okay. A vector can be resolved into infinite number of components. Clear? A vector can be resolved into infinite number of components. But we are using a componentization called rectangular componentization. Okay. Here, this is a right angle triangle and this is theta. If this is Ax and this is Ay, this is Ay, this is also Ay. So what is A? What is A? Modulus of vector A is called A. That means not considering this head, only considering this tail. Okay, we can only consider this tail, that is A. A is equal to root of Ax square plus Ay square. If there are three componentization, this componentization is called Az. Okay. It is also written as root of Ax square plus Ay square plus Az square. So simply vector A, it can be represented like Axi plus Ayj plus Azk. What is Ax? Component of A in the direction of x. What is Ay? Component of A in the direction of y. What is Az? Component of A in the direction of z. The representing unit vectors are I, j and k. Okay. And also in resolving method there are another type of questions that is called componentization questions. That means vector A, this is a force. How we can combinize this force? Like this. If this is theta, it is F cos theta and this is F sin theta. Consider this is a lawn roller. Okay. I am applied a force F on the lawn roller. This is called push. Okay. And what about this? This is pull. We can combinize this push and pull force. Irrespective of their locality in space, a vector can be transformed. That is the important statement in this chapter. Equality of vectors. Okay. This vector F can be replaced like this. Same magnitude, same direction. Head, same direction. Okay. So this vector F can be resolved like, yes, this is theta, angle made with horizontal. This is F cos theta and this is F sin theta. Okay. And this is pull. This can be resolved like this. Angle is theta. This is F cos theta and this is F sin theta. Ready? So here F cos theta is the component of force in the direction of motion. Hey, we are pushing on this body. That body moves like this. So F cos theta is the direction of component of force in the direction of motion. This is the direction of motion. Here f cos theta is only involved in the motion, but here f cos theta, we are pulling this body, so body moves like this. Here also f cos theta is involved in the movement. Okay, detailed study about this concept comes in laws of motion. Okay, so this is called resolving. A vector can be resolved into two components in rectangular componentization. Okay, process of splitting a vector is called resolving. Process of splitting a vector is called resolving. From the concept of resolving, we have to find out the magnitude of a vector. This is vector axi plus ayj plus azk. We can find out the magnitude of that vector like this: a equal to root of x square plus ay square plus az square. So if this is a vector a, 2i plus 2j plus 2k, how we can find out mod a? That means magnitude of a. 2 square plus 2 square plus 2 square, take the root. 4 4 4, root 12 is the magnitude of this vector a. Okay, so like this we have to find out the magnitude of vectors. For that purpose we are resolving vectors. So resolving of vector means splitting of a vector into infinite number of components. But here we are using rectangular componentization. Why it's called rectangular? Yes, clear. Next one, directions using vectors. Directions using vectors. Consider a plane. This is our plane, and this is north, this is east, this is south, and this is west. Okay, so there are 4 directions: north, south, east, west. And next one, there is another 2 direction, upward and downward. What it means? This is our plane, and this is north direction, this is south direction, this is east direction, and this is west direction, and my head is in upward direction and my leg is in downward direction. These are 6 dimensions. Okay, east, west, north, south. Here north represents direction by using north can be represented by using plus j cap, and south minus j cap, east plus I cap, west minus I cap. Okay, this is plus I cap and this is minus I cap. Upward direction can be represented by using plus k cap, and downward direction can be represented by using minus cap. What is the purpose of this representation? Just solve this question. A man moves 10 meter north, then 2 meter south, then 4 meter east. Oh, a man moving 10 meter north, 2 meter south, 4 meter east. What is his displacement? While we are calculating this question, like a 3-dimensional picture in our mind, a man is in north and then he moves 2 meters south, then he moves 4 meters east. It's very difficult. But by using vector, we can solve this question very simply. How? 10 meter north, what it means? 10 j cap, because north represents j cap. 2 meters south, what it means? Minus 2 j cap. Yes, south means minus j cap. Okay, and next one, 4 meter east. What is east? Plus I cap. How much? 4i cap. Ready? 4 meter east means 4i cap. 2 meter south means minus 2j cap. 10 meter north means 10j cap. This is his displacement S. How we can find displacement? It is root of 10 square plus minus 2 square plus 4 square. Okay, this minus 2 square is 4, 10 square is 100, 116. Okay, root of 100 plus 4 plus 16, that is root 120 is the answer. Root 120 is his displacement. Clear? Another question. A man moves 10 meter west, 2 meter east, 3 meter upward direction. 3 meter upward direction. How we can find the displacement? By using three-dimensional picture, it is very difficult. 10 meter west, then 2 meter east, then 3 meter up. But by using vectors, we can solve this question very simply. 10 meter west means west minus I cap. So minus 10 I cap. Then 2 meter east plus 2 I cap. Then 3 meter upward direction. 3 meter upward direction. What it means? Plus 3 k cap. 10 I cap plus 2 I cap is 12 I cap plus 12 I cap plus 3 k cap. Ready? Here there is no j vector. So answer is root of 12 square plus 3 square. Root 12 square is 144 plus 9. This is the answer. 144 plus 9 is root 153. Root 153. There is a simple mistake in this question because this is 10 j cap and minus 2 j cap. I am taking this j cap as I cap. So this calculation is wrong. We have to calculate 10 j cap and minus 2 j cap, that is 8 j cap plus 4 I cap. Here is no k cap. So answer is vector s is equal to this one. So mod s is equal to root of 8 square plus 4 square, that is root 64 plus 16 is the answer. Okay, calculate this one and you will get the answer. Clear? So directions by using vectors. What is our important point? Which unit vectors represents directions? Which are the unit vectors represents direction? Upward direction, that is plus k cap. North plus j cap. East plus I cap. Downward minus j cap. South minus j cap. West minus I cap. These are the representation vectors. Downward minus k cap. Look at the question and put the values involved or by including directions by using vectors. So we can find answers very clearly, okay, very easily. That is directions using vectors. So we have discussed about north, east, south, west. There are another some directions. Which are they? North, south, east, west. What is this direction? This is northeast and this is northwest and this is southwest and this is east south or southeast. How we can represent northeast by using unit vectors? How we can represent northwest by using unit vector? How we can represent southeast by using unit vector? How we can represent southwest by using unit vector? It's a very important shortcut in physics. So please listen. Northeast direction represents, what is north plus j cap? What is east plus I cap? So northeast means plus I cap plus j cap by root 2. That is northeast representation. What is northwest representation? Northwest representation is plus j cap. What is west? Minus I cap. plus j cap minus I cap by root 2. What is southeast? Listen, west is minus I cap, south is minus j cap. So minus I cap minus j cap by root 2 is clear. Minus I cap minus j cap by root 2. And last one, southeast. What is southeast? Plus I cap minus j cap, plus I cap minus j cap by root 2. These are the representation of northeast, southeast, southwest and northwest direction by using unit vectors. Please listen a question. A man moves 10 meter southeast, then 20 meter northeast. What is its displacement? Displacement S is equal to 10 meter southwest. What is the representation of southwest? Representation of southwest. For simplicity, question can be changed like 10 root 2 meter southwest, 20 root 2 meter northeast. Okay. So 10 root 2 meter southwest. What is southwest unit vector? Minus I cap minus j cap by root 2. Okay. Then plus 20 root 2. 20 root 2 northeast. What is the representation of northeast? Plus I cap plus j cap by root 2. Okay. How you can calculate this one? This root 2 get cancelled, root 2 get cancelled. Here minus 10 I cap and minus 10 j cap plus 20 I cap plus 20 j cap. This is the displacement vector. Minus 10 I cap plus 20 I cap. Resultant is 20 minus 10 I cap. Minus 10 j cap plus 20 j cap. Resultant is plus 10 j cap. This is vector S. What is modus? Modus is equal to root of 10 square plus 10 square. That is equal to root 200. That is 10 root 2. Ready? That is the answer. So, a man moves 10 root 2 meter southwest, then 20 root 2 meter northeast. What is his displacement? While we are calculating by using 3-dimensional picture, it's very difficult. But by using vectors, we can solve this concept by directions using vectors. Northeast, northwest, southeast, southwest. The representation unit vectors are these. And put that value to the question and solve it. Find the magnitude, we get the result. 10 root 2 is the answer. Okay. One more example. A man moves 10 meter southwest, 20 meter northeast. What is his displacement? Southwest. 10 meter southwest. 10 into south minus j cap west minus I cap by root 2. Plus 20 northeast, north plus I cap plus j cap, east is plus northeast plus j cap, east is plus I cap by root 2. Clear? I cap plus j cap by root 2. This is displacement vector S. How we can calculate S? Minus 10 j cap minus 10 by root 2 j cap minus 10 by root 2 I cap plus 20 by root 2 I cap plus 20 by root 2 j cap. Ready? Representation of southeast, southwest, northeast, that we are already discussed. So this is the displacement vector as j cap. This is also j cap. Minus 10 20 minus 10 by root 2 j cap plus 20 by root 2 j cap. What is the resultant? This and this one. Okay. Answer is 10 by root 2 j cap. And this is minus 10 by root 2 I cap. This is plus 20 by root 2 j I cap. So answer is plus 10 by root 2 20 minus 10, minus 10 plus 20, that is plus 10 by root 2 I cap. This is vector s. How we can find as root of 10 by root 2 the whole square plus 10 by root 2 the whole square. Ready? Calculate s equal to root of, what is 10 by root 2? 10 by root 2 is 10 by root the whole square is 100 divided by 2 plus 100 divided by 2, that is 50 plus 50, that is root 100, that is answer is 10, answer is 10 meter. So what is the displacement of this man? That is 10 meter. Okay, this is a previous year question. Southwest, northeast, 10 meter, 20 meter. What is the displacement? Answer is 10 meter. So we can calculate this answer by using vectors, directions using vectors. Okay. Next one, angle between vectors. Angle between vectors. If this is vector A and this is vector A, this is vector B, what is the angle between these two vectors? If this is 120 degree, what is the angle between A and B? Simply it is 120? No. Angle between vectors means angle between their tails. That means this is head and this is head and this is tail. This is head and tail angle 120 degree. So we can rewrite it like this is vector B, same magnitude, same direction. So this is vector B. This vector A can be moves because irrespective of their locality in space, vector can be moved. This vector K and A can be represented like this. This is vector B, this is vector A. Okay. This is vector A. Replacing like this. This angle is 120 degree. Yes, this angle is 120 degree. Total is 180 degree. Right. Total angle is 180. This is 120. Then what is this angle? 60 degree. So angle between these two vectors is 60 degree, not 120 degree. Angle means angle between their tails. Okay. Angle means angle between their tail. This is angle between head and tail. Always join their tails. Okay. This is called co-terminal vector. So co-initial vectors. These are called co-initial vectors. So we have to find out angle between two vectors by only representing they are starting from a common point. They are starting from a common point. Look at this question. Vector A, vector B, vector C. Vector A, vector B, vector C. If vector C equal to vector B by 2, then what is the angle between A and B? We have to find out angle between A and B. But this is not that angle because this is head and this is tail. Okay. So this vector A can be moves here. So this vector A can be plotted as like this. This is vector A. Equal magnitude, same direction. Okay. Equal vectors. So this is that angle. So we have to find out this theta first. Then total is 180. If we have to know this theta, then we can find out what is this angle. This is the angle between A and B. Okay, not this one. So we have to find out this theta. What is sine theta? Sine theta is equal to vector C divided by hypotenuse. Vector B. What is vector C? It is vector B by 2. Already there is vector B. So vector B get cancelled. Sin theta equal to 1 by 2. What is then theta? Theta 30. Sin 30 is 1 by 2. So theta is 30. Clear. So this angle is 30. Then what is this angle? 150. So angle between, because total is 180. If this is 30, this is 150. Okay. So angle between vector A and vector B is 150. So what is the important point in angle between vectors? Angle can be measured, angle can be calculated by using a common concept, that is head and tail angle. between tail and tail, that is they were originating from a same point. Clear? That is about the angle between vectors.